Chapter 4, From Cells to Organ Systems, Screencast 4. Now, we are probably talking now about the most important regulatory mechanism within the body, and we're introducing those systems that are responsible for maintaining homeostasis. Now, homeostasis is primarily defined as maintaining a relatively constant set of conditions in our body. So things that we regulate are going to be blood pressure, blood glucose levels, pH, body temperature. Those are all things that the body is responsible for regulating and keeping within narrow limits. How the body does this is through negative feedback control systems. So this is important. We're going to introduce two different control systems, but only one of them is going to be homeostatic in nature, and that's going to be negative feedback mechanisms. Now, positive feedback mechanisms are not homeostatic in nature, and they're going to take us further away from what we refer to as set point. Okay? Now, when we look at the components of a negative feedback loop, and that's what we're going to use, think of a thermostat in your home. That's a really, really good example. Now, the components involved or making up a negative feedback system are going to be the controlled variable. So using that thermostat example, temperature. There's a sensor. Okay, so that's basically responsible for detecting what temperature is. There's going to be the control center. So if you've got one of those fancy wireless thermostats, okay, that's going to take a look at how it's set. You may have it programmed and so on. And then you actually have the effector. Now, depending upon the heating system you have, that's going to be connected to either the furnace or the air conditioner. Okay, so that's a really, really good example. So kind of think about it. When temperature goes down, it gets picked up, okay, within your home by the thermostat. Thermostat recognizes, integrates that, comes with a decision, looks at what the programming is, and then it turns on the furnace so that the heat comes on until you reach your set point again. Okay, so that's a really, really good example of the components of a negative feedback loop. So that's something you should be very comfortable with. Now, as I said, these are the major components, so the controlled variable, and that could be something as body temperature, blood pH, blood glucose levels. All of those are things that we control and regulate pretty tightly. Now, the sensor in our body, that's going to be a receptor, and what that's doing is it's basically monitoring, okay, to make sure that that set variable or controlled variable is where it's supposed to be. Then there's the control center, and that is connected to the sensor, and that's where the input is going. So the input is picked up by the sensor, and that's connected to the control center. And then we can think of that as an integration center. As I said before, kind of depending upon your programming, okay, it's going to exchange input or output to the effector to make sure that that control variable is where it's supposed to be. Now, the effector is what's taking action to correct the imbalance. Now, another important factor when we talk about a negative feedback mechanism or feedback loop, so you want to keep in mind the change is in one direction, and the body is going to go the opposite direction to bring it back to where it's supposed to be, or the set point. It's really easy to think about temperature. So when temperature drops, the body is going to do things that are going to increase body temperature until you're back to 98.6 degrees or our set point. Okay, so that's really important when we're talking about these control systems. So here's a really good example. So the controlled variable, we have the set point. Here's what it's supposed to be. So this is what's happening when it's too low. Okay, so there's the input. The sensor detects the change. I go to the control center, and then basically the effector is going to bring it back to its set point. Here, same thing, except now that control variable is too high. Same thing, but instead now the body is actually going to bring it down or decrease it. Okay, so that's really important that you understand how these controlled mechanisms actually work. Okay. Now, the best example that we've seen quite often is maintaining body temperature. So in this particular example, the controlled variable will be body temperature. The sensors, we have actually temperature sensors located within our skin and internal organs. The control center is our hypothalamus. That's a region in our brain that's really responsible for a lot of really important things. Behavioral drives, thirst, hunger, things like that, all sit within the hypothalamus. So that's part of the central nervous system, a sub-area within our brain. Now, the effectors are going to be blood vessels, sweat glands, skeletal muscle. Okay, so those are the things that are going to be activated by the control center to bring temperature back to what its set point should be. So here, exactly what we saw previously, except now we're looking at core temperature. So it's really cold out. Okay, we've got sensors within the skin and internal organs which detect that. They're going to send that information to the hypothalamus. And then the hypothalamus is going to do a couple of things. It's going to increase activity to skeletal muscle. So you're going to start shivering. Okay, that's waste heat in an effort to heat the body. And then also the body is going to focus on protecting the core. You're going to see blood vessels actually constrict within the periphery. Okay, and all of those mechanisms hopefully are going to bring temperature back to where it should be. Now here it's kind of going to be the opposite. And remember what I said previously. So here is what's happening. The response is in the opposite direction. So now temperature is going up. The body has to do things that are going to cool it down again. Same receptors. Now we're looking at the same control center. And now we're going to increase activity to sweat glands. And now we're going to vasodilate blood vessels in an effort to promote heat loss. Okay, so you should be really, really comfortable with these examples of negative feedback mechanisms. They are homeostatic. That's important. Now, there are another type of feedback mechanisms which are called positive feedback. These are not homeostatic. They actually take you further away. So an example that I like to use, so kind of imagine you're driving around, you hear a song that you really like. What do? You crank it up because you like that song. Then a crappy song comes on and then you kind of turn it off, okay? Because you don't like that, all right? So here you're getting further away. So what's happening here is there's an amplification. Probably the best example that some of you may be familiar with if you've had children is the process of childbirth, okay? There's not just one contraction and boom, out comes the baby. Okay? It's a whole bunch of contractions and there's more of them. So there's an increase in frequency and then they get stronger or more forceful and they will continue until birth has occurred. So the thing that you want to remember here, positive feedback mechanisms are not homeostatic. That's important. So you don't want to reverse them. Negative feedback mechanisms are homeostatic. Positive feedback mechanisms are taking you further away from that set point.